In this section, we'll be talking about term weighting. In the previous section, all terms are evenly weighted. However, in the real world, it's not likely that all words in documents are of the same importance. According to Zipf's law, the frequency of any word is inversely proportional to its rank in the frequency table. Thus, the most frequent word will occur approximately twice as often as the second most frequent word, 3 times as often as the third most frequent word, etc. The rank frequency distribution is an inverse relation. If you investigate by yourself, you will see that the most frequent words are usually in our stop words list, like the or a, which are not informative. The terms that are super rare might not be truly informative as well. They could be author's custom writing that you won't see anywhere else, or even typos. The terms that have moderate frequencies could be the most useful ones. We will not make the definition so quickly. The 3 different ways of term weighting we are showing as follows take advantage of these frequencies. Let's see how they perform. We will use the plot description of the movie Rocky as an example. The first term weight strategy is term frequency. The numbers on the right side show the times of a word appears in a plot. Most of the frequent words are too general to deliver useful information, which is in according with the findings of our Zipf law. Inverse document frequency is defined by log of n, which is the number of documents, divided by the document frequency of terms, which is the number of documents where term T appears. If the term appears in many documents, IDF will become smaller. In other words, this is about how unique a term is. If it is unique, then inverse document frequency will be high. If the term is common, then inverse document frequency will be low. This strategy sees the rare terms we talked about earlier. The terms ranked higher may seem actually weird, like dozen, which is after bad tokenization. We can do better of actually using the contraction expansion. And addering is actually misspelled. We want to combine both of them by multiplying them. We pursue some balance between importance in the document and the uniqueness among corpus. Now we have very representative features. Instead of Adrian, we have Adrian. I like this analogy that shows the similarity of TF-IDF, term weighting, and the character. TF-IDF accentuate terms that are frequent in the instance, but not frequent in general, while character exaggerates traits that are characteristic of the person compared to the average. If you are applying for a job or something, you want to highlight the important strings, but also those that are unique to you. A lot of the most crucial skills for doing any job are the most common. For example, being generally polite and professional, or being able to write a coherent sentence. But if you are just highlight those, you won't stand out. If you pick just your most unique skills, like being able to judge or something else, those might not be as important for success in a job. So you want to pick things that have a mix of importance and uniqueness. So let's take a look at some questions here.